Hello, everyone. I want to talk about bonding, ionic bonding, electronegativity, stir that all together in this video. And then in subsequent videos, we'll continue to talk about bonding and properties of bonding. So, again, what is a bond? What is a chemical bond, actually? It's a general force of attraction between two atoms. It's not any type of line or a stick or glue or anything like that. It's an invisible force between two atoms. And typically, if we talk about a chemical bond, it's going to be an electrostatic, an opposites attracting type of attraction here. And why does bonding occur? Because it decreases potential energy. Single atoms tend to be tend to have a ton of energy, and we want to bring that energy down by reacting. And when we react or cause bonds to occur, then we end up with something that has lower potential energy and is definitely more comfortable, if you could use those terms. But that's why bonding occurs, is to lower potential energy. Okay. Now, bonding is based off of something called electronegativity, and we haven't talked about electronegativity yet, so let's do this now. So electronegativity is defined as the tendency of an atom to attract electrons while it's in a bond. And yeah, I'm kind of yelling at you here when I say in a bond, because it sounds like electron affinity, but it's not. It's electronegativity. And again, when two atoms are bonded, they share electrons, or they might share electrons. When they share electrons, they're going to be pulled towards the atom that has the higher of the two electronegativities. So where are the highest electronegativities? They happen to be on the top right-hand corner of the periodic table, which means the bottom right-hand corner has the least amount of electronegativity, and I have a graph right here for you. Okay, so notice the top right-hand corner, fluorine has the highest electronegativity, whereas cesium in the bottom left-hand corner down there at the, you see CS down at the bottom left-hand corner, that has the lowest electronegativity. Okay, so when we take a look at these types of bonds with electronegativity in mind, we have to think of that there are, quote, three kinds of bonds based on electronegativity. Now, there's really just two. There's ionic and covalent, but we're going to break the covalent bonds down to two further subcategories called polar and nonpolar covalent bonds. So let's talk about ionic bonds. When we have an ionic bond, there's a humongous difference between electronegativities, because you're going to now take a metal, which typically is, let's take a standard metal, which is on the left side of the periodic table, group 1, with your standard nonmetal, which is group 17. The electronegativity values are so huge here, where group 1 really wants to give up electrons and group 17 really wants to gain electrons. Okay, we know that because of electron affinities and ionization energies. Now, when they get together, the group 17 has such a strong pull on those electrons, and group 1 has such a weak pull on those electrons that they don't bother sharing. They actually transfer electrons. Perhaps there's one electron here. They actually transfer the electron all the way to group 17. That causes this to be overall positive, this to be overall negative, and we have an electrostatic attraction between the two, and they bond in what's called an ionic bond. So you need to understand that there is a complete transfer of electrons. Yeah, the pull is that strong by group 17. Okay, so it pulls the electrons so hard that it actually transfers them over, causing ions to occur and thus an electrostatic attraction to result. The second kind of chemical bond is called a covalent bond. And again, we're going to break those down to two subcategories, polar and nonpolar. So let's talk about polar covalent bonds now. Electronegativities are different here, but they're closer, okay? Why? Because they are between two nonmetals. So if we take a look at the upper right-hand corner, we are going to see these form, generally form polar covalent bonds. Of course, this is included in this over here. So again, they're between two nonmetals that are not the same, okay? So between O and H, or N and O, or P and O, or S and Se, or C and Cl. Okay, those are polar covalent bonds, okay, because they're between two nonmetals that are not identical. Okay, so what do we have here? So what we have here are basically electrons that are not shared equally. Why? Because they're not identical and they have different electronegativity values. So much so that it's not quite strong enough like an ionic bond to pull the electrons completely away, and it's not weak enough where they're shared equally. They actually share them unequally, where the stronger electronegative, more strongly electronegative atom, I think I said that right, is pulling the electrons towards it. That causes that side of the molecule to be slightly negative and the other side to be slightly positive. Okay, more on that later. Okay, So again, polar means the electrons are not distributed equally. The second category again is covalent bonds, but we're going to break that into a second subcategory called nonpolar covalent bonds. And this occurs between two nonmetals with the exact same electronegativity value. These tend to be like a twinning type effect. So think of Professor H. Broncliffe, H2Br2, O2N2, etc. And this is where the electrons are shared equally. So they go back and forth across that bond between the two. For example, if we take a look at Br bonded with Br, okay, the electrons, these are exactly the same, the left and right bromine. So the electrons go back and forth across here, and they don't prefer one or the other, okay? Whereas if we go back to this slide here, and if I have something like HCl, this is much more electronegative than hydrogen. So the electrons love to be around the chlorines more than they like to be around the hydrogens. So if they're around the chlorines more often than the hydrogen, then this side is definitely, it gets the essence or slightly negative. I'll explain that in a little bit. And that to be slightly positive, okay? So that's a polar covalent bond. And of course, we know, going back to ionic things, they are also there's humongous electronegativity values where there's actually transfer of matter. Okay? That's it for electronegativity. We'll move on to something else. If you have questions, please email.